you. All right, yeah, so we were doing that one. I went ahead and answered the rest of the questions. Remember, that's the one where we found the inverse function. Did that make sense? I was kind of rushed through that right at the end of class. So then I've answered the rest of the questions. Let me go through those, like why those are the answers, because this is a tougher one. I think there is one like this on the final, if I'm remembering right, where I give you something and ask you for the inverse. I think it is important. So here, let's do it again real quick. So y equals minus 3 cosine 7x. So that's the, it was f of x, but f of x is the same as y. So, and then remember how you find an inverse function? Oh, are you here to do that?
Whenever you're ready.
Okay. So we're going to do, so let's find inverse function. So remember, how do we find an inverse function? Number one, we switch or invert, if it helps you remember it, x and y. Number two, solve for y. Right? So to find the inverse function here, switch x and y. You're welcome.
Thank you, guys.
So switch x and y, solve for y. So let's do that again, like we did last time, just to make sure it's clear in your mind. I think, like I said, I think it is on the final. So switch those two. X goes here, y goes in there. So they just literally switch positions, everything else stays put, right? That's an inverse, inverting, x and y, inverse function. And then solve for y. It's all about y saying, I want to be alone. And so we got to get rid of this minus 3. So it's like peeling an onion, right? You do the outer layer first, then you go on down to the middle. So you got to get rid of the minus 3, get rid of the cosine, then finally get rid of the 7, and the y will be alone, right? So first off, how do we get rid of the minus 3? Well, that's just division. Just divide both sides by minus 3. So we got x over minus 3 is cosine 7y. Now how do we get rid of the cosine layer? That's inverse cosine. Yeah, that's where the inverse part comes in. Because what gets rid of a function is its opposite, huh? The opposite and the regular undo each other. So I do cosine inverse on both sides, like that. Does that make sense? Because the cosine inverse cancels the cosine. Like a poison and an antidote. They neutralize each other, right? If I swallowed a poison, the doctors would give me an antidote, and they would eliminate each other, neutralize each other. So that's what we're doing. The way you get rid of the cosine is not dividing. That is a common mistake sometimes people make, right? They'll have this. They'll have x over minus 3 is cosine 7y. I'm on the screen, yeah. And they'll think you can divide by cosine on both sides. You can't do that because that's not multiply. Real important as you move forward into calculus that you're comfortable with that concept, right? Because the parentheses kind of make us think at first it's kind of like multiplication, but it's not. It's a function. It's more like f of 7y, right? That doesn't mean multiply, does it? That means the 7y plugged into the f. Likewise, this parenthesis 7y does not mean multiply. It means 7y plugged into cosine. So that cosine is not multiplied. It's plugged into the toaster. That's why I always use the toaster analogy to help you think of a function that way. So you can't divide by cosine. Instead, you have to do cosine inverse of both sides. And when you do, like a poison and an antidote, they cancel here. And so we just have the 7y, and this is cosine inverse of x over minus 3. Last step to get the y totally alone is divide by 7. Boom. So there it is, 1/7. I'll just put the 1/7 in the front. Cosine inverse of x over minus 3. So that's the inverse function. Switch x and y, solve for y. That's what I typed in right there as the answer. Then, now, there's a couple other questions they're going to ask. I bet you guys can figure out how to do this. The domain of f is the same as the range of what? F inverse. And vice versa, what is it? There'd be the range of f is the same as what? The range of f is going to be the same as the domain of the inverse. Yeah, because that's what a function and its inverse do. Everything switches, right? So domains trade with ranges. Remember, domains is x coverage, range is y coverage. So yeah, so keep that in mind as they're about to ask us a bunch of questions about domain and range of the regular function and the inverse function. Really, there's only two things to do. If we get the domain of both of them, then swap, that's the range of the other one. You know what I mean? So when they say down here, what's the range of f? I've already answered it. Where am I getting that from? The range of f, well, the range of f is the same as the domain of f inverse. Well, okay, great. How do you know what the domain of f inverse is? I don't know. How do we know what the domain of f inverse is? What would be the easiest way to do that? Oh yeah, let me change my plan. I mean, we could do it that way, but that's not the easiest. We will use this information, but let's do this. What's the range? So there's one other key fact I need to make sure you're clear on. If you have, think about cosine for a minute, or sine. Let's do sine. Here's sine. Cosine's the same thing, right? Sine or cosine, what's the range on a normal? It's down, graphing it down here in the corner. What's the range of a normal sine or cosine function? Yeah, range means vertical coverage, right? Up and down. How high, how low. How low does a sine or cosine go? -1. How high? +1. Normal. Normal sine and cosine. The range, the vertical span, the up and down, is -1 to +1, right? That's for normal. Now, that'd be like for sine x or cosine x or something, right? Y equals. Now, what if they threw a number in front, like a 3 sine or 3 cosine? What's that going to change? Well, then it'll go up to +3 and down to -3, right? That's the amplitude. It makes it go higher and lower. We've seen that in the previous section about graphing. Well, that's what we have here, right? A 3 in front of cosine. -3 doesn't matter. It just means it's upside down. But the 3 means it's going to go 3 negative, or from -3 to +3, huh? So that's why that's the range right there, from -3 to +3. That's the range of the original function. Then they say, okay, what's the domain of the inverse? Well, same as the, right, these are going to be the same. Domain of the inverse is the range of the original, isn't it? So I just copy that one. And then they say, what's the range of the inverse? Am I going too quick? Did you get this last one? Domain of f inverse, same as range of f. Now, what's the range of f inverse? Range of f inverse? To get the range of f inverse, like it says over here, range of f inverse is the same as the domain of f. Well, what's the domain of f? They gave it to me right here. They said it. They just handed it to me, silver platter. Domain of f. They said, here's your function f, and here's the x values that you can go with. So that's the domain. Does that make sense? They're giving me the domain. They are saying only go x from 0 to pi over 7. So that's why this answer is 0 to pi over 7. Because it's the domain of f, and it's the range of f inverse. And that's all the questions. Make sense on that one? All right. Pretty much if you can do these, you can do a lot. Because it has a lot in it. It has inverse functions, it has range and domain questions, it has sine, cosine, thinking. It's a lot of these. All right, let's try that one. So find the inverse. F of x equals 2 sine 4x minus 3. Find the inverse function. So I'm just going to call it y equals. So switch x and y, right? Oops, missed it. So switch x and y, solve for y, right? So get y alone, go layer by layer. Get y alone. So first layer, divide by 2. Good to there? Now, next layer, we're trying to get down to y. Next layer, we got to get rid of that sine. How do we get rid of that sine? That's where the inverse comes. We can't divide. Again, that's not multiply, huh? We got to do, that's plugged into the toaster, plugged into the function. So we have to do sine inverse of both sides. And the sine inverse cancels the sine, like a poison and an antidote. They eliminate each other. So then we have sine inverse of x over 2. These are both gone. So it's just 4y minus 3. We're getting closer. Now just add the 3 and divide by 4, huh? So just add the 3 to both sides. Sine inverse of x over 2 plus 3 is 4y. Last step, divide by 4. There it is. There's the inverse function. Is that good? And then they're going to ask you all the other questions, you know, domain and range of f and f inverse is basically what they're going to ask you. Maybe we could answer that real quick over here. So I'll say, all right, what's the, well, first off, they're saying find the inverse. Okay, then they're going to say, that says it up here, range of f. Okay, so what's the range of f? Let me give you a second. See if you can find the range of f. That means the original function. Here's the original function f. 2 sine. 2 sine. So think about the graph. Oh yeah, sorry. I got to plug in my pen. It just died. I always forget to do this. I should have done it this last hour when I was sitting in my office. Sorry. I forgot all about it. So yeah, so to do the range of f, you got to do the up-down, right? It's going to be from -2 to +2, isn't it? You good on that? That's the range of f. And then that's going to be the same thing as, that's the range of f. That'll be the same as the domain of f inverse, right? Which will be their next question. And then, this pin advertises it'll work for 30 minutes on a 30-second charge. So we'll see. Give it a 30-second charge, give about 5 more seconds. Apple boasts this will happen. We will see. All right, put it to the test here. That was 30 seconds. That's all you get. All right. So it's working for now. All right. So yeah. So the range of f is -2 to +2 brackets, right? Because it's right on -2, right? Because the sine graph would. Whoops. Sine graph would go. Whoops. That looks funny. But anyway, from -2 to +2, right? So brackets. It hits both those spots. All right. So there's the range of f. That's the same thing as the domain of f inverse. They're both the same thing. And then finally, it's going to ask for the domain of f. What's the domain of f? It's right there. They gave it to me. They handed it, silver platter. Right? They said, here's f, and here's the x values you can do, meaning here's the domain. Right? So the domain is 3/4 minus pi over, right? Literally just exactly like that, comma, 3/4 plus pi over 8, just like that, with brackets because you hit both those endpoints. And that is also the range of f inverse, isn't it? And we're done. Is that good? So we can handle functions and function inverses for trig, for sines and cosines and tangents and stuff. Is that good? You like seeing trig a second time? I basically took pre-calculus 2 times in high school. Not really. I had the algebra 2, and my algebra 2 teacher was very fast and aggressive, and so we basically got into pre-calculus, and then my senior year I took pre-calculus. And it was like doing the same math again. It was great. I got it. The second time, I really got it. So I don't know if you'd like seeing trig again, if this makes more sense than before. Tim?
So if the domain isn't given, would that mean it's infinite?
Yes, right, because the sign can go forever to the right and forever to the left. That's right. They don't say it'd be an infinite domain, all reals. That's right. Inverse stuff here. There's another section I wanted to cover today. Probably not finish it. All right, so 3 cosine inverse 5x is 2 pi. Can you solve for x there? That's what they mean, exact solution. So once you get x alone, x is saying, I want to be alone. So give that a try. So here's the wall. X is saying, I want to be alone. So go layer by layer, you know. Start with the 3, but it's like peeling an onion, right? Start with the outer layer, get rid of that 3, then get rid of that cosine inverse, and then get rid of that 5. Right? Start in the outer layer, like an onion, right? Until you got x alone. So first step, get rid of that 3. All right, cosine inverse 5x is 2 pi over 3. Good. Next step, we got to get rid of that cosine inverse. How are we going to get rid of that cosine inverse? Cosine. Exactly. I can't divide. Remember, again, it's not multiplication. But you do the opposite. The opposite of cosine inverse is regular cosine. Exactly. And then they just cancel each other out, don't they? So I'm just doing regular cosine there. Everybody with me? Gets rid of it. And so then that's 5x is regular cosine 2 pi over 3. Last step, just divide by that 5, huh? Divide by that 5. So it's 1/5 cosine 2 pi over 3. There it is. Is that good? Is that making sense? Questions? Yeah.
Why did you move the 5 up and make it 1/5?
Oh, you don't have to. You can totally leave it like this.
Okay.
Both are good. Tim?
Would they want you to solve the rest of the way, like cosine of 2 pi over 3 divided by
Oh,
5?
they do. You're right. I'm forgetting. We can do that one, can't we? Yeah, I'm just leaving it. No, we're not done. Yeah, that's right. So we got to figure out what is the cosine of 2 pi over 3. I forgot. I just thought that was some crazy angle, so who cares? Just leave it. No, we got to get an answer. You're right. So that so we got to plug that in. That's 180, right? Putting that pi is 180 degrees. So I don't even know what that angle is right now. What is that? It's 120. Okay. So let's figure that out over here. You're right. So 1/5 cosine of 120 degrees. See how I figured that out? Because it's 2 times 180 over 3, right? The pi is 180. I always change the degrees. I just think better in degrees. 3 goes into 180 60 times. 2 times 60, 120, right? So cosine of 120, all right? No calculator. So how do we figure out cosine of 120? Unit circle. Draw a little. Yeah, where's 120? 120 is, yeah, here's 90. Here's 180. So 120 is, yeah, right there, isn't it? It's 30 past the 90. Yeah, right. Yeah, so some of you guys always do reference angles, which what you're saying, that'd be great. It's the same as the reference angle, 60 degrees. Reference angles are always to the x-axis, so exactly 60 degrees is right. That's the same exact angle. You could do that. I'm just gonna leave it where it's at. Doesn't matter either way. Just leave it right there. So remember, it's a small, medium, large thing, right? So it's back small, up large. Back a small amount, up a large amount, right? To get to 120. So back a half. Remember the small, medium, large. 1/2 root 2 over 2 root 3 over 2. Small, medium, large. Remember that? So back a half, up root 3 over 2. Now, is the cosine. Cosine x or y? Cosine is x. Grab the x value, negative a half. So it's 1/5 times negative a half. Cosine is x. Right? So that's negative 1/10. Yeah, that's the real answer. Negative 1/10. There we go. Questions on that one? Okay. Just keep wanting to skip these, but I guess we better do it. All right, try that one. Solve for x there. 19 cosine inverse x minus 3 pi equals cosine inverse x. There's the wall. X is sitting a little below. So do you realize what you need to do first? Well, I mean, there's a couple ways to go. I'm going to subtract 19 cosine inverse of x from both sides, because this is 1 cosine inverse of x. This is gone. Minus 3 pi is minus 18. See how that worked? It's big old like terms on the right side. Right? 1 cosine inverse minus 19 cosine inverse is minus 18. cosine inverse. Just treat them like big old like terms. See what I'm doing? So then just divide by the minus 18. And that's pi over 6. We good to there? What we can do at this point? Get x alone. Got to get that cosine inverse off of it. So what do? Cosine of both sides, right? So we'll do a cosine of both sides, cosine of both sides, and the cosine cancels the cosine inverse, so we get cosine of pi over 6 is x. All right, find the value of each of the 6 trig functions of the angle theta in the figure. So there's theta right there. So they want us to find the value of each of the 6 trig functions. So they want us to figure out, the sine, the cosine. So like, what's the sine of theta? What's the cosine of theta? What's the tangent of theta? And then the other ones are reciprocals. So, all right, so how do we do that? So we got to remember the other the triangle definition for the trig functions, which you guys all remember, right? What is sine? I mean, I've been saying he's y over r, or just y, which is true. But in a triangle, yeah, the hypotenuse stuff, right? Remember that? Sine is what? What's the opposite over hypotenuse? And cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Remember that kind of stuff? That's the same thing as the YR. Let me show you. But first off, how do you memorize that? Well, you probably already got it memorized. But SOHCAHTOA, right? You guys know that? SOHCAHTOA. That's the, right? Sine opposite over hypotenuse. Cosine adjacent over hypotenuse. Tangent opposite over adjacent. SOHCAHTOA, right? It's the same thing as what we've been doing with the Y's and the R's. Let me show you. I want you to see it's the same thing. Suppose you have a spot, some dot, some angle theta, right? If you make a triangle there, I've been saying, look, cosine is the x value, right? Cosine is the x value, cosine of theta, and sine theta is the y value over r. It's technically over r. I've just been putting them in a unit circle with r1, so we've been able to say it's just x and y, right? Well, that's the same thing. If you take this angle cosine, for example, say cosine of theta is what? Opposite, and this is adjacent, opposite over hypotenuse, which is r. See, cosine is O over r. So, wait a minute, that's not working. Oh, because cosine's not opposite. You guys got to say something when I do that crazy stuff. It's adjacent. Well, therefore, it's x. Yeah, say something when I do something crazy like that. You guys aren't even listening. You're like, Mr. Aaron's being crazy again. All right, cosine of theta is adjacent over hypotenuse, is what it actually is. And the adjacent is the what? X. See how that's the same thing? And the opposite is the what? Is the y. So when you do sine theta and it's opposite over hypotenuse, it's y over r. See how it's the same definition? Same thing. It's a different way of saying the same thing, isn't it? All right. So getting back to this, if sine is opposite over hypotenuse, here's sine. What angle, do you understand the opposite adjacent stuff? Let me make sure you're clear on that. If this is the hypotenuse, right, because it's the side across from the right angle, the side not touching the right angle. The other two sides, they hit the right angle, don't they? The other two sides hit the right angle, but the hypotenuse doesn't. Now, from theta's perspective, B is the opposite side, and A is the side hitting theta. That's what adjacent means, next to you. Your neighbor lives adjacent to you, next to you, right? So sine of theta being opposite is B over hypotenuse. And I don't know what the hypotenuse is. I got to figure out the hypotenuse. How do I figure out the hypotenuse? Yeah. Pythagorean theorem. A squared plus B squared is C squared, right? A is 13, B is 10. 13 squared plus 10 squared is C squared. What's that? 169 plus 100, right? So 269. And then root it. Root of 269. So B, 10 over the root of 269. but you can't leave a root in the bottom, blah, blah. I'm fine on a test. I don't care. But we should get rid of the root from the bottom. So we get some space here. So multiply top and bottom by the square root of 269. And so that's 10 root 269 over plane 269. I don't think 269 is rootable, is it?
No, it's prime.
Yeah. Is it prime, actually?
Prime.
Oh? You just know that's prime?
Nothing, whenever I was in high school, I just divided it by all the basic numbers and nothing happened, and I tried other higher numbers. It worked.
Okay. It looks prime. Certainly has that look. So cosine of theta is adjacent over hypotenuse. So that would be 13 over root 269. Again, we got to get rid of the root. So multiply top and bottom by root 269. So we get 13 root 269 over plane 269. And then finally, tangent is opposite. Tangent's easier. Tangent is b over a, huh? I only have to mess with hypotenuse. It's just 10/13ths. Like that. We good? And then they're going to want the other three, which are upside down, aren't they? So if you have sine, I don't have room over there on the right. Then, well, here I'll just do it. I don't have room. Cosecant. Can I squeeze? Yeah, it's just upside down. Now I don't want to flip this one upside down because then again I'd have the root on the bottom. Why don't I just flip this one upside down? Right, so that'd be root of 269 over 10. And then cosine flipped upside down is secant. Secant, again, I'm going to just flip this one upside down so I don't have to mess with the root stuff on the bottom. 269 over 13, root 269 over 13. And cotangent, flip the tangent upside down, 13/10. There we go. We got the 6 trig functions for theta in a triangle, and you already knew that before you even registered for this class. So you could have done that problem probably. Questions on that one? Remember all that stuff, the SOHCAHTOA stuff? And it's the same as the y and the r stuff. We just use SOHCAHTOA. Now, do you know when you use them? You use SOHCAHTOA when you're in a right triangle. You use the y-r stuff when you're on the unit circle, right? Is that good? Because when you're in a right triangle, the biggest that angle could be is 90 degrees, huh? So you're in the first quadrant of the unit circle. You following that statement? Why can I say that? Why is the biggest that angle could ever be in a right triangle? Why is the biggest any other angle could be in a right triangle 90 degrees? How much does a triangle hold? 180. So if one of them's already using a 90, all you got left is 90. So angles in a right triangle are always going to be 90 or below. Or below 90 technically, right? So that's really saying you're in the first quadrant of the unit circle. So basically right triangle trigonometry is first quadrant unit circle trigonometry, isn't it? That's what it is. All right. So B is 2, beta. So the way that the naming scheme, they'll put the same Greek letter across from the English letter. See how beta is right across from B? Beta is the Greek. They just use Greek letters for the letters. I mean, that did make sense. Greek letters for the angles. And then alpha's across from A. That's what they'll always do. So just know that's what they mean whenever they say these things. So when they give you B and they give you beta, know those are across from each other because they're both B's in different languages. So, all right, so B is 2. Beta is 66. And they're saying, hey, find A. How can I do it? There's actually a few different ways. But he got one of the ways. How can I find A, given that beta is 66 and B is 2?
Start with the other.
Yeah, you can get the other angle. Yeah, if you wanted. So the other, because this is 90 here. So 90, so that 90 and 66. Or you could just say, look, the other two make 180. No, I'm sorry, the other two make 90. Because the triangle holds 180. I'm already using up 90 with the right angle. So let me just subtract the 66 from 90, whoops, subtraction, and I'll get, what is that, 24? So this one's got to be 24 degrees, because that makes 90, and then the 90 right angle is 180. So, okay. But how do I find the little a now? It doesn't really technically help my cause to find little a. So basically you want some, let me clear up your thinking. Think this way. You want some trigonometry relationship that involves those two things. Let's just pretend we didn't get to 24. It just doesn't really matter. It's okay. It just doesn't really directly help. You need some trig relationship that involves the 66, the 2, and the a. Because you're trying to find a, and then you need those numbers. So what trig relationship involves the 66, the 2, and the a? Tangent. Tangent of 66 being opposite over adjacent is 2 over little a. See how I came up with tangent instead of cosine? Let me show you why another one wouldn't work. I think that'd be more instructive. What if I'd say, well, I'll just do sine? Okay, well, if you did sine, that wouldn't be a good plan. Here's why. Sine of 66, opposite over hypotenuse, would be 2 over c. So I would have sine of 66 equals 2 over c. Well, I don't want c. I want a. See how that wouldn't be a good plan? Now, you might say, okay, yeah, I see that sine's not a good plan, but because I want the a. But how about cosine? Cosine would involve the a, yeah, but that's not a good plan either. Let me show you why. Cosine of 66 being adjacent over hypotenuse. What's the adjacent? Well, there's my little a. What's the hypotenuse? I don't know. See the problem? The reason you don't want cosine is because, look at that, you'd have two unknowns. I don't know a, I don't know c. I can't do anything with that. Tangent's the way to go. Because with tangent, you only have one letter that's unknown, and you can solve for it. So you see how I determined to use tangent? I just looked at the two things they gave me and the thing I wanted and said, what connects that angle, that side, and the a? Tangent. All right, so how do I solve this for little a? Got to get an a by itself. So what do I do? Here's something I see a lot. A lot of people will take this and they'll say, well, I got to get rid of that 2, so just divide by the 2. You can tell by my tone, this is wrong. But I see this a lot. I see this a lot on the exam. Maybe 30% of the people do this on the final. There's usually one of these in the final. And I'll see that. That's not right. That a's in the denominator. All of a sudden, now he's like regular. That's not right. You can't do that, right? See the difference? See the problem with that? Right? That would be true, but anyway, we don't want the a's in the denom. So let's go back. What do we do then? I would put this over 1 and diagonal. Because you got to get that a out of the denominator if you're trying to solve for it. So then you would get what? You would get a tan 60. I wouldn't get the number on the tan 66 yet. I'd wait till the end to get that number. Equals 1 times 2. Everybody see what I did there? Just diagonal, cross multiply. Now you can get the a alone. Now a tan 66 is 2. Divide by the tan of 66. There we go. A is 2 over tan 66. Now just hit the buttons on your calculator, with tan 66. Round to 100th, 2 places, and you got your answer. Tim?
Did you use the law of sines to find it as well?
Yeah, that's a nice way to go. Yeah, we haven't talked about that, but you're totally right. Yeah, the law of sines. You guys remember the law of sines? Alpha, or sine, I'm doing tangent. Sine of alpha over A is sine of beta over B is sine of, usually it's gamma or whatever you want to call it, over C. Yeah, so notice sine of any angle and the side opposite it have a consistent ratio. That's the law of sine. So yeah, that would work really well here because we have these two already in their ratio. We have this whole fraction, and we're looking for A, and we actually found alpha too. So you can do that. That'd work great. I won't go into the details. Want to see that? Grab me after. Either way would be fine. Good? Questions on that? Notice they want me to find more. Anyway, we'll do it on this one. All right, try that one. Is that on the screen? No, that's off the screen, isn't it? Here, let me redraw it here. So you know how it goes. It's beta with B, and A with alpha, and this is C. That's how they always make them. It's always that same way. So there we go. So find the stuff. Oh, and they're telling me little c is 6, So they're giving me the hypotenuse. And beta, or B, I guess it's just B on this one, is 80. 80 degrees. That's all they're giving me. Okay, so give me those two. All right, see if you can find little a. So look for a relationship involving little a, the 80, and the 6, right? Everybody see what we're looking at? Little a is what we want, first off. And we have an 80 and we have a 6. So look for some trig relationship involving the 80-degree angle, the little a, and the 6. Let's see if you can figure out what trig relationship connects the little a and the hypotenuse. So that's the adjacent of the hypotenuse, isn't it? Right? If you're looking at 80, the A is his adjacent side. The B would be his opposite side. The little a is the side next to the 80. That's the adjacent side. And the 6 is hypotenuse. So what trig relationship involves adjacent over hypotenuse? Cosine is adjacent over hypotenuse. So you want the cosine of 80 degrees to be little a over 6. Does that make sense where we want to start? Cosine is adjacent over hypotenuse. So solve for little a. How do we solve for little a? Multiply both sides by 6. Boom. So 6 cos 80. And so that's just one you would do on your calculator, right? Because 80 degrees is not one of our memorized spots, right? So just hit the buttons on your calculator. Somebody got it? What's little a? What's 6 cos 80? Negative 4 or 5? Oh, not 80. Oh, yeah, no. Oh, no, 80 is small. No, it's going to be small, huh? I'm getting totally confused. It's positive. How could A be negative? It's the side of a triangle. That was a dumb statement. All right. So it's got to be positive, and it's small. It's like 1 or 2 or something, right? 1.04? Thank you. 1.04. Okay. So there's little a. Oh, yeah, 2 decimal places. That's perfect. 1.04. Now, beyond that, now that we have a 1.04, they want you to find the little b. So how could I find the little b? I could notice. Let me suggest something. You could do the Pythagorean thing at this point, right? A squared plus b squared c squared. The only thing is, it's fine with me on a test, but you may get a rounding error though because you're using a rounded number. So generally, Math Excel might give you a little trouble. It's fine on a test. Feel free to do that. I'm not real picky about one little decimal rounding thing on the test. But if you want to make Math Excel happy, which I know you live to do, you probably should go back to the 80 and the 6 and the b. That way you're not using rounded numbers. You know you'll get exactly the right thing. So what trig relationship involves the 80, the b, and the 6? Because that's opposite over hypotenuse, isn't it? So that's sine. Yeah, sine of 80 is b over 6, right? That way you'll directly get b. You won't use a rounded number. Now, actually, it's okay to use a rounded number if you used a few more digits of accuracy, like 2 or 3 more. So yeah, basically, if you're going to use a rounded number in a further calculation, just go a few more places, and then it'll all be fine. But if you cut it right sharp and then use it, it might be an error, right? You might throw off the other answer. All right, anyway, multiply by 6 on both sides, boom. And so 6 sine 80 is b. That's going to be something like 4 or 5? 5.9? 5.91? Or is it round that way? 5.91. So we got, what else do they want? We got A, we got B, and they want the capital A. Oh yeah, what's capital A? How do we find angle capital A? Yeah, subtract from 90, right? Because it's got to be 10 degrees. Because 80 and 10 make 90, plus the other 90 is 180 in the triangle, right? The other 2 angles always make 90 when you have a right triangle for 180 total. And we got them. That's everything they want. Good questions on that one? because no angles are given. You have to do something a little different. Let me give you a minute to see if you can figure out what to do. They're giving me A is 3, C is 5, well, right, yeah, other than the 90. And they want me to find little b. Oh, little b, that'd just be Pythagorean, right? We can do that quick. That's no big deal. A squared plus b squared is c squared. Yeah, I would just use Pythagorean for that. Right? And you know, what is it? 3 what? 5? 4. Yeah, 3, 4, 5 is such a common Pythagorean triple, they call it. It's good if you just have memorized 3, 4, 5, 5, 12, 13. They use those two all the time. Those are two very common Pythagorean triples. You'll see them in do calculus. You'll see them all the time. If you just know them, it'd save a lot of work. Just, 3, 4, 5. 5, 12, 13. They're not always, but they're often using those two they're called Pythagorean triples. So anyway, so b is going to come out to be 4. If you solve this thing, 9 plus b squared is 25, subtract 9, b squared is 16, b is 4, as we knew. So b is 4. Now, here's the part I really wanted to get to. Alpha. Here's angle alpha. How are you going to find angle alpha? We don't have any of the angles. We got all 3 sides now, 3, 4, 5. Yeah, that's right, I keep saying that. Other than the 90, we don't have the other 2 angles. How are we going to get one of those angles? Yeah, we're going to have to do an inverse trig. That's what you got to do. In other words, so like if you're doing alpha, for example, you can say, okay, alpha, I'll just do sine, or cosine, it doesn't matter. You can do sine or cosine. I'll just do sine of alpha is opposite over hypotenuse, right? Opposite over hypotenuse. It's 3 over 5. So sine of alpha will be 3/5, right? So then sine inverse. Yeah, and you'd need your calculator for this. This would be on part 2 of the final where you have your calculator. You would need your calculator. So so we would just do sine inverse on both sides, right? And these cancel. Alpha's alone. Sine inverse of 3/5. Take your calculator out. Hit the buttons. Make sure you're in degree mode. What you got? 36.87. And we got alpha. Now, once you got alpha, you can find beta by subtracting from 90, right? So then beta will be 90 minus 36.87. That's something 53.13. So we got beta. So we got it all. So see how we did that? When we don't have any angles other than the 90, we have to do you could have done any kind of trig function, really. We could have done sine, cosine, tangent, because we had all the sides. It didn't matter. Any trig function would have worked, then the inverse to get the angle. All right, well, we didn't quite finish this. This won't be due till Thursday. But we did finish the other one. What was the other 7.1? 7.1 due Wednesday. 8.1 will be due Thursday. And we're almost done. So we will start review tomorrow. Well, I mean, I'll finish the last, whatever it is, 4 questions, and then we'll dive right into review as fast as we can. We'll start reviewing for that final. What's that? The old exam? I'm going to put the answer keys up for the 4 exams we take. Yeah, by the end of the week. Yeah, so that's what I'm going to start going over.